All right, so we're in lesson 3 of chapter 4 today. So chapter 4, lesson 3 is called Area of Trapezoids. In our green math books, we should be open to page 168. So pause and please get your book open so you can see where those examples are pulled. So today our learning target is I can find the area of a trapezoid. So we'll enter that in first into our notes. All right, so at the top of page 168, you'll see our key idea there, and also you'll see an example of a trapezoid. So we're going to start out by drawing one of those trapezoids. So let's list the title. Here is a trapezoid. There's a couple of different kinds that you're going to see in this chapter. So basically what you're going to see is a set of parallel sides that may or may not be the same as each other. So the traditional trapezoid has one longer on the top, on the bottom, and the one on the top is shorter. And they're going to have these kind of slanted sides coming out of it, like so. That's kind of your traditional trapezoid. Again, we have the height labeled, so I'm going to label H. So H is going to stand for the height of the trapezoid. And on this particular shape, we actually end up with two bases. This on the top we call a base, and this one on the bottom we also call a base. So we're going to call this one base 1 on the top, and then this one base 2. So base 1 is going to stand for the first base, and it really doesn't matter which one of these we call 1 and which one we call 2. Excuse me, that should have been a 2. Base 2. So you need the height of your trapezoid and you need two bases in order to find the area of a trapezoid. So now let's talk about the actual formula. How are we going to do this? So here is the area formula of a trapezoid. So what we are going to do is take the height and we're going to multiply it by, and we're going to put parentheses around this, we're going to add up the two bases. So base 1 plus base 2. So we're going to first start inside the parentheses. We're going to add up the bases. Then we'll multiply it by our height of the trapezoid. And then lastly, we have to cut it in half, kind of like we did with our triangle. That is a terrible straight line. Let's try that again. Ooh, okay. Divide it by 2. So again, we have to use PEMDAS here. We have to use order of operations. So we have to add in the parentheses. Then we'll multiply that by our height, and then we'll cut that in half or divide by 2. So that's the process when we find the area of a trapezoid. So we're going to practice doing that. One more thing on the side up here, there's some other types of trapezoids you might see. So one might look a little like this, where the top base and the bottom base are still different than each other, and you've got this slanted side, but instead of having this be slanted, it actually comes straight down. That's another type of trapezoid that we might see. And then sometimes they'll tip a trapezoid over on its side, and it'll look kind of funky, like something like this. So you have a trapezoid that's kind of tipped over on its side. So just a couple other extra examples of different styles of trapezoids we might see. All right, back to 168. Example 1 says finding areas of trapezoids, and we have two examples under number 1. So an A and a B that we're going to be looking at. So in our notes, example 1, we have an A, we're finding the area. So let's draw this first trapezoid. So it does not look as traditional as our example up top, but I did show you one like this. So it's just got one slanted side and the other side kind of comes straight down. They also give us a little box here that tells us that's a 90-degree corner. So it goes straight up and straight over. They are giving us some measurements. The top measurement is 5 feet. The bottom measurement down here is 9 feet. And then this measurement over here is 6 feet. So that's what they've given us, and they want us to find the area. So looking back up at our vocabulary, we need the height, and we need both our bases to be able to find the area. So the height here is going to be how tall the trapezoid is. That's going to be 6. And then up here is 5. That's one of our bases. And 9 is our other base. So our height is 6. We're going to multiply the 6 by our 2 bases added together, and then we have to divide all of that by 2 or cut it in half. So that's what the area stands for. So we're going to add the middle first. So 9 plus 5 gives us 14. So this, I can write a 14 above there. Then we're going to take 14, multiply it by 6, which gives us 84. And then that 84 we're going to cut in half, which gives us a total of 42. So our final area would be 42 feet squared. Remember that label of the units squared has to go on our area. So breaking that down a little bit further, if 5 plus 9 is 14, then I have to multiply by 6. So on the top, really what I'm doing is taking 84 and cutting it in half. That's how I get my 42. So this trapezoid is 42 feet squared. Looking at item B from example 1, this one's a little bit more traditional looking trapezoid. We have a top line and a bottom line. This line goes a little longer. Sides are a little bit more slanted. They're giving us this height here and a box telling us it's 90 degrees. That's going to be 5 meters. The top is 8.5 meters and the bottom is 11.5 meters. So that's the trapezoid they give us this time. So go ahead and write out our formula. Notice that we've got some halves involved, some decimals. So remember, we start with our height. Our height here is 5, so we're going to put that 5 on the outside of our parentheses. And then we have to add up our bases. So we have 8.5 plus 11.5. And then we take that whole thing and divide by 2. So let's break this down, and we're adding these decimals, so not terrible when you're adding halves. So if you're adding 11 and a half and you're adding 8 and a half, that would be 20 total here. So this would give me a 20. 11 plus 8 is 19, plus the 2 halves would give another whole, so that's 20. Then I have to multiply the 20 by 5. That would give me 100. So I have 100 divided by 2. My final area, 100 divided by 2 is 50. And then I'm going to put my label on 50 meters squared for this trapezoid. Go ahead and pause the video and look at the bottom. You've got 2 try on your owns there. Pause and try finding the area of those 2 trapezoids. Okay, if you tried number 1, that one gives you 30 millimeters squared. And if you tried number 2, that one gives you 30 inches squared. All right, moving right along. This next one is a multiple choice question, but really we're doing the same process on a grid. So we're going to write example 2. I'm going to try and draw this trapezoid to scale using my boxes. So try to do your best if you don't have squares on your journal. If you do, try to draw it to scale. So what we see here, it says, what is the area of this trapezoid? On the left, you can see that the left-hand side of the trapezoid is 2 boxes long. So I'm going to make this left hand 2 boxes long. I'm going to try to make that a little straighter. There we go. And then on the right, you can see it goes over and down a little bit. So it goes over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and down here. And this line is just 1 box long. And then we connect the tops together. Ooh. And the bottoms together. So we're using the grid lines now to come up with the actual answer to our height and our bases. So someone has tipped over this trapezoid. So you can see that the 2 bases that are supposed to be parallel are on the sides rather than the top and the bottom. So this we would call base 1, this we would call base 2, and our height would actually be this distance all the way from one side of the trapezoid to the other. So we're going to call that h. So for finding the area here of this trapezoid, the h, let's count how many boxes long it is. We have 1, 2, 3, 4, 5, 6 boxes. So we're going to start with a 6 in our formula. One of my bases here is 1 box long, plus this one is 2 boxes long. And then we have to cut all of that in half. So if we go in the parentheses, 2 plus 1 would give us 3. 6 times 3 would give us 18, and then we have to cut it in half, which would give us 9. And it doesn't look like we have any units here, so we'll put units squared. If you look at the choices they've given you, A, B, C, and D in your book, our final answer would be C, because that gives us 9 units. Moving on to example 3, they're going to give us one here that kind of goes more into a real life situation. Here we go with example 3. Looking at page 169 still, it says you can use a trapezoid to approximate the shape of Scott County, Virginia. The population is about 23,200. About how many people are there per square mile? So if you look over to the right, you'll see the little map, and you can see that Scott County is pretty close to being a trapezoid shape. So if we take that little trapezoid out and draw it out in our notes, we can go ahead and do some math work with it. So the top has got a shorter line. This side slants a little bit. This side slants a little bit more on that map. That's kind of the shape of that county. And we can put the name of it over here. We have Scott County. And it also tells us that the approximate population of Scott County is 23,200 people. We're going to need to use that in our work, so we'll add that to our notes here. Okay, some labels they give us. So this top bar they give us, the top base would be 15 miles, and the bottom is 38 miles. And then they tell us the height of our trapezoid here is going to be 20 miles. So the first thing we'll want to do is go ahead and find the area of our trapezoid. So here we go. Area equals, we start with our height, which is 20. Then we do our parentheses. 15 plus 38 are our two bases. And then we take all of that and cut it in half. So we have 15 plus 38. So I think that's 52. Correct me if I'm wrong. We have 52 times 20, and we take that and we cut it in half to give us 530. So 52 times 20. Okay, well, 2 times 0, those would be zeros. We put a 0 in our placeholder. We've got 4. 2 times 5 is 10. So we have 1,040 as 52 times 20. If we take that and we cut it in half, divide it by 2, 2 can go into 10 5 times. 2 can go into 2 times. 2 can go into 0 times. I ended up with 520. Let's make sure we ended up doing this correctly over here. 8 plus 5, 8, 9, 10, 11, 12 is 13. Sorry, we should have had a 3 there. That changes this number a little bit. See, teachers make mistakes too. This should be 53 times 20, not 52 times 20. So this ends up getting us a 6. So we have a 6 here, and this should be a 3. So it ended up with 530. So we have 530 miles squared for our label, 530 miles. If we go back to the question, it says about how many people are there per square mile. So what we have to do here is take 530 square miles and 23,200 people and divide them to figure out about how many people are there per square mile. So if we go on to this second page here, put a little asterisk, because this is what we're trying to solve. How many people per square mile? So in order to solve this, we're going to have the 530 square miles on the outside of our bar. And then we would have 23,200 on the inside of our bar. So it's a great thing that you guys get to use calculators on this, or you'd have to start practicing your long division here. So what you would notice if you take and divide this on your calculator, you would end up putting 23,200 in your calculator first, divided by 530. And when you do that, you get about 43.7 in your calculator. So if we're saying about, we can round that off to the nearest human instead of having a 0.7 of a person. So we can say about 44. That would be our final answer for how many people per square mile, about 44 people. And that brings us to the end of our lesson. If you want to pause and do the last two got it's, or on your own, excuse me, to the bottom of page 169. Okay, so number 3, find the area of this trapezoid on the grid. You should have got 10.5 units squared, or 10.5 units squared. And number 4, it says about 1 person per square mile. So 22,650 people divided by 530 miles squared is about 43 people per square mile. Okay, we can stop the video.